Hey guys, next problem in Thevenin's theorem. Okay, this is a problem in Thevenin's theorem. This is a circuit diagram given. So one voltage source and one current source, and this will be the load resistance and R1 and R2 and R3. So 5 ohms, 4 ohms, 20 ohms. So this is the circuit diagram of Thevenin's theorem. So the question here is you have to find how much load current is flowing through the load by using Thevenin's theorem. Okay. So as I explained already that you have to find first Thevenin's equivalent circuit diagram. So for this circuit diagram, you have to find Thevenin's equivalent circuit diagram. So this is a Thevenin's equivalent circuit diagram. What is the statement? The voltage sources can be replaced with single voltage source. So that is called VTH, and all the resistances can be replaced with single resistance is called RTH, and VTH and RTH should be in series. This is the statement of the Thevenin's theorem. So this is the equivalent circuit diagram and load resistance will be same. So for this equivalent circuit diagram, you have to calculate how much load current is flowing. So it means simply IL is equal to total voltage by total resistance, right? This is the basic formula. So total voltage VTH divided by RTH plus RL. Both are connected in series. So this is the procedure. Okay. Now let's start finding of VTH step by step. So you have to follow the steps. Procedure is very important. Okay. First, step one, finding the VTH. So what is the first step? To find the VTH in the major circuit, in the main circuit, we have to remove the load resistance. Again, then you have to redraw the circuit diagram. So here I removed the load resistance. Then you have to draw the circuit as it is. So this is a 3 amperes and 25 volts and 5 ohms resistor and 20 ohm resistor and 4 ohm resistor are connected as it is. And look from this side and you have to calculate. So VTH nothing but the voltage across nearest branch of the load resistance. So if you look from this side, what's the nearest branch? This is 20 ohm resistor is the nearest branch to the load resistance. So if you find voltage across this resistor, that will become a VTH. So to find voltage across this, we have many procedure, many solutions. So you can take nodal analysis by using Kirchhoff laws, and okay, and so you can find this voltage across this one. Okay, so first VTH across this is equal to VAB and VOC. So nothing but VAB, nothing but the voltage across this. So this term was same, these two nodes. So this will be the nodal analysis, and this is the voltage across the nearest branch. So if you find this is also VT is also called open circuit voltage. Why? Because we open terminals here, the voltage across these terminals are same. Here, 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 they will be same parallel. So therefore, we have to find the VTS. Step one. So at this node, we have to. So what are this is the junction? So the some currents are going like this, and some current is going like this, and this is the current is coming upward. So at this junction, at this node, we have to find, you can apply KVL also, or KVL KCL also, right? So the incoming currents are, some of the incoming currents are is equal to some of the outgoing current. So one current is coming like this. If you write the equation for this current, so what the current equation? Potential difference by resistance. So we can write this current equation here. So this V is equal to 25 minus by 25 V minus 25 by 5. So what is the V? Okay, this is the V. So we assume that this is the final voltage and this is the lower voltage. So we are finding, because current is coming like this, we assume that this is V is higher than this 25 volts. If we go reverse, we can assume this is higher than this one. So now for time being, for this process, so we assume that this is the current. So this is the current coming. So V minus 25 is the voltage potential difference between these two terminals. Therefore, I can calculate potential difference divided by resistance. I will get current. So this is the V minus 20 by 5 plus, and voltage, the current coming, which is through current is going, which is 20 ohm resistance. So the current going 20 ohm resistance is equal to voltage across this branch divided by resistance. So what is the voltage across here? V by 20 is equal to so sum of the incoming currents, right? These are the outgoing currents, and this 20 amperes current is coming like this. So this will be the incoming current. So sum of the outgoing currents I1 plus I2 is equal to I3. So this current is coming inside, the current is already given, only to calculate here. So therefore, if you simplify this equation, V minus 25 by 5, so we can write V by 25 minus 20 by 5 plus V by 25, 20 is equal to 3. So V by 25 minus 25 by 5, 5 1 jar, 5 5 jar. So minus 5 plus V by 20 is equal to 3. So V by 5 same, and so I'm rearranging this equation V by 20, and so this minus 5 I'm shifting to this and transporting to this side. So when you transpose, this will become plus, right? Okay, so here take the V common, 1 by 5 plus 1 by 20 is equal to 8, and the V 1 by 5 is 0.2, 1 by 20 is 0.05, and V, and this will become 0.25, that is equal to, therefore V is equal to 8 by 0.2, we'll get 32 volts. So now we got this V is equal to 32 volts. Now we got VTH. So this is the way of finding the VTH. Next, step 2, we have to find, so we got VTH, we have to find RTH. So what is the procedure for RTH? So voltage source in a given circuit, voltage source must be short circuited and current source must be open circuited. So how many voltage sources are there? Only one voltage source is there, one current source is there. So then again you have to remove the load resistance, and voltage source must be short circuited and current source must be open circuited. So we are making simply it is 0. Then calculate the total resistance of this circuit when looking from this side, load terminals A and B. So when you're coming from this side, this become again branch node. So here current will gets divided. Okay. Therefore, when current gets divided in the branch, so these two resistance are connected in parallel. Therefore, 5 parallel to 20, and in this resultant will be in series plus 4. Therefore, parallel resistance, when two resistance are connected in parallel, the resultant resistance is equal to product by sum plus 4, that is equal to 100 by 25 plus 4, then becomes 8 ohms. So this is called RTH. This is the procedure is very important. Remove the load resistance. If any voltage source you find, you please short circuit, and any current source you find, and make it as open circuit. Okay, so now we got RTH and VTH. This is the equivalent circuit diagram. So we got VTH 32 volts and RTH equal to 8 ohms. So RL connected as it is. Now step 3 is very easy, right? So step 3 is equal to, we have to find load current. Load current is equal to, what is the total voltage VTH, what is the total resistance RTH plus RL. So IL is equal to VTH by RTH plus RL. So VTH 32 volts and RTH 8 ohms. RL is given 10 ohms. RL is 10 ohms. So therefore this answer will be 1.77 amperes is the load current. So from this circuit diagram, so we got this current of 1.777 amperes. So this is the answer. I hope you understand. If you don't understand, please write your comments. So please mention. So I'll reply. And thank you so much.